Hey everybody, your Friendly Math Tutor here with our Practice Module 2. This is the hard section. So again, the first video was the Module 1, and typically if you get more than around the 14, 15, 16 range, you're going to get the hard module. So this is always our goal. We need to get to this hard module to really have a high score. So now I'm going to work through a hard module. So here in number 1, we have a equation that's in slope-intercept form, and it wants the best interpretation of 36. So basically, we want to notice that 36 is in the position of the slope, and the slope is rise over run. So I like to just write, it's like change in y over change in x. And what we want to do is look at the change in y as kind of like the p. So that's the budget, all right? So it's really the budget in thousands of dollars. But I'm just going to put budget is what's changing up here. And then this is per year, all right? So it's really the change per each year. So we look, number of years, that doesn't make sense. The amount budgeted in thousands in just this year, that doesn't work. The annual increase in thousands of dollars each year, that one is what makes sense. And it's not the number of years. All right, so you might have been able to just get C, but I did want to go over kind of how we go through that thinking using slope. All right, on to number 2. So which expression is equivalent to that? Multiple ways to do this. We could use a couple different ways. What I like a little more like advanced strategy would be let's pretend this was, let's say, 9x squared minus 4. The way you would factor that is you would do a difference of two squares. You would do 3x minus 2 times 3x plus 2. So I'm going to do something similar. Notice this 3 is the square root of 9, and this 2 is the square root of 4. So I'm going to do the same thing, but I'm going to use 2x and 2x, then 1 plus 1 minus. But now 3 is not a perfect square, so I'm going to use root 3. Then when I have 2x plus root 3 on the bottom, my 2x plus root 3s are going to divide out, and I'm going to be just left with 2x minus root 3. It's a bit of an advanced move, but it's a nice, quick way to do a problem like that. All right, let's keep it moving here with number 3. What is the y-intercept? All right, you can just throw this into Desmos, or you can know that a y-intercept is whenever x equals 0. So I simply just get y equals 7, 3 to the 0 minus 5. 3 to the 0 is 1. So 1 minus 5 is negative 4. Add the 7 over, and you should get 3. But again, Desmos is a nice, easy way to do that as well. I just thought it was pretty easy to plug in as well, and I really like the concept of y-intercept make x 0. Okay, number 4, we have, again, another linear model. At birth, this is the weight. At 180 days, this is the weight, which is the function that gives the mean weight of a calf X days after they're born. Well, if we imagine when we substitute in, because it's days after they're born, and they're born at 34, so basically 34 should be our y-intercept, so these two don't work. Then it's about finding either the slope or plugging in. I'm going to find the slope. So we want to think about the change in weight is 272 minus 34 over the 180 days. You can think of it as like 180 minus 0 if you really like the slope formula. So 272 minus 34 divided by 180 is going to be 1.32. So that's the increase in weight, or in weight in kilograms per day. So the answer is C. All right, on to number 5. We have evaluating functions. So f of 1 is t. That means when the input is 1, what's the output? So that means t is equal to 3. Then when they want f of 3t, well, 3 times 3 is 9. Well, f of 9 is going to be 15. So pretty straightforward problem there. You just got to be able to evaluate functions using a table. And now on to number 6. So we have a chart by approximately what percent did the average cost of housing increase over this period? All right, so basically it just went from 122 to 169 because, yeah, it doesn't say, oh, yeah, it wants the percent that it increased over the whole period. So it doesn't want like an average per year, just again, reading it closely to kind of confirm that. So we're going from, what's the percent increase from 122 to 169? The way I like to do it is just simply divide the numbers, final divided by original. And so 169 divided by 122 is 1.39. And multiplying something by 1.39 is a 39% increase. So it's going to be C. So when you just divide them, if you get a number bigger than 1, you take 1 away, and what you're left with is the percent increase. And if it's less than 1, then you do 1 minus that. So for instance, if you got like 0.85, that would be a 15% decrease. This is obviously an increase, so that part doesn't apply. But again, just like to kind of talk about all the concepts here. All right, number 7. All right, so we need the interpretation of 3 to the t over 14. So basically, this is going to always be our initial amount in an exponential model. So it's like we started with 2034 bacteria. Which of the following is the best interpretation? So it's basically just that value there is going to be doing this to it over a certain period of time. That's the best way I can explain it. Multiplying by 3 is going to be tripling it, and it's going to be doing this every 14 days. So it's just that tells us that the amount is going to be tripling every 2 weeks. The number of bacteria at the beginning of the study is 2034. It doesn't increase by 3. That would be adding 3. That's a linear model. And then just the number after 2 weeks, that would be actually multiplying 3 times 2034. So that's not what they're asking about. Okay. Moving on, we have number 8. So these are equivalent, and we want Q plus R. So essentially, it really just wants us to factor this. So let's see if we could do this by factoring, and then see at what point can we stop the problem. So we have 12x squared minus 8x minus 15. So that's just what we get when we factor out the x squared, which we, obviously, so now they're the same. So now we just have to factor this. So what we can do is the AC method. So if I do 12 times 15, I get, well, really 12 times negative 15, I get negative 180. So I need two numbers that multiply to negative 180 and add to 8 and negative 8. That's going to be negative 18 and 10. And then simply I'm going to ignore this x squared now. So now I have 12x squared minus 18x plus 10x minus 15. Factor by grouping, going to take out a 6x, and I'm going to be left with 2x minus 3. And then I'm going to take out a 5, and I'm going to be left with 2x minus 3. I could stop here, but I will just show you the last step. So 6x plus 5 times 2x minus 3. So now I know Q and R are 6 and 2, and when I add them, I get 8. Yeah, I know. Let me know in the comments if you found a quicker way. I just figured if we factor it, it's kind of a big number to factor. It ends up being a little not too difficult because we're multiplying by 10, but still, I wonder if there is a way to somehow use Desmos and figure out what this looked like in factored form. But yeah, I just thought just powering through doing the AC method would get us to the answer. Okay. Number 9. So here we are with line A and B are parallel to each other. A goes through these points, B goes through this point. What's the equation for line B? So if they're parallel, they have the same slope. So I'm just going to find the slope of these 2 points. So the slope is going to be 6 minus 0 over 0 minus -4. I'm really writing that out just so we don't make any silly mistakes. So 6 over 4 is 3 over 2. So if it's parallel, then the slope has to also be 3 over 2. And then what I'm going to do, I'm going to just plug in. We could find the equation, but I'm simply just going to replace x with -6 and see which one gives me 0. So for this one, I'm going to do 3 over 2 times -6 plus 6. And -6 times 3 halves is -9. And -9 plus 6 is not 0, so that answer is wrong. So it has to be this one, right? -9 plus 9 would give us 0. All right, so I like, instead of actually writing the equation of the line, I eliminate 2 answers, and then I just plug into 1, and then that's all we have to do. All right, let's keep it moving here to number 10. The exterior angle of an equilateral triangle is equal to that. What's the value of x? Well, if you imagine having an equilateral triangle, all the angles are 60. And then if I extend one of the sides, the exterior angle would have to be 120. So therefore, we're just going to have 8x minus 20 equals 120. And this is pretty easy to solve, so just add the 20. 8x equals 140, and 140 divided by 8 is simply just 17.5. All right, number 11, how many solutions does the equation have? So what I am going to do is I'm going to use Desmos. And I had mentioned on another video that I don't love using Desmos for solving number of solutions, but I really meant like a certain way to plug it in. So I am going to solve this. I'm going to show you 2 ways to solve this, and then you kind of decide. So let me hop over to Desmos here, and the first way that people use to solve using Desmos is simply plugging in the equation directly as is. And this is a fine way to do this one. So I'm going to zoom out a bit, but yeah, so we only get one vertical line, so there must be just one solution. All right, so that's totally fine. Another way to do it is to put the left side in one and the right side in the other and look for intersections. And so we see that there's just going to be one intersection. So again, 2 different ways to do the same thing. It's your preference, except for if I go back to the problem. So we know the answer is 1. The issue with the first way is this one doesn't matter because there's no infinite solutions, is that if there is 0 solutions or infinite solutions, when you just plug in the equation, they will look the same. Let me just demonstrate that really quickly. So I know that if I do something like 2x plus 3 equals 2x plus 3, there's an infinite number of solutions, and Desmos just simply doesn't show anything. But if I make it 2x plus 5, there's no solutions, and Desmos also doesn't do anything. So those are the types of problems where I wouldn't use this way because you can't decipher the difference between infinite and no solutions. Then I would simply take this equation and plug it into the second one, and then you'll see that they're parallel. And in the first case, they'd be on top of each other, and you'd be able to decipher between no solution and infinite solution. This problem didn't matter because there was no infinite solution option, so it was totally fine to do it the first way. But the second way will work as well, left side in one, right side in the other, and look for how many intersection points. All right, let's move on to number 12. Which of the following coordinates would be true? This is another one. I would just use Desmos. So I'm going to, again, hop over to Desmos, and I am going to just, just put it in as is. So y is greater than negative 2x minus 1, and then 3y is less than x plus 9. And what we have to realize is that the answer is over here in the double shaded region. All right, that's the solution region or the solution set. So which could be true for the whole system. So I'm just going to plug in the answer. So answer choice A is negative 3, 3. And you can see that that's wrong because the point is not in the double shaded region. Then I'm going to do negative 2, 1. And that is wrong because that's only in one shaded region. Then I'm going to do 1, 4. And that is wrong. So clearly the last answer, 3, 1, is the only one in the double shaded region. So therefore, that is the answer, which is D. All right, here we are in number 13. So what we have here is a system problem where they're talking about the types of solutions. And this is one where I don't think it's a great idea to use Desmos because two reasons. It's open-ended, so we don't have values to put in for the slider. And we also have two sliders going on here, which could be a lot of guessing and checking if you are doing it that way. So I'm going to show you the non-Desmos way to do a problem like this. A system has infinite solutions if you can make both equations look exactly the same. So I'm going to multiply the first equation by negative 2, and I'm going to get negative 18x plus 28y is equal to 6. And the second equation I'm going to leave alone because now I just look at it and say, okay, what do I need to make these to be exactly the same? So I know it doesn't ask for it, but A would need to be negative 18 and B would need to be negative 28. Because if B is negative 28, then I'm going to get a positive 28 here, and they're going to be exactly the same. And when they're exactly the same, we have an infinite number of solutions. All right, which of the following is an equivalent form that displays the x-intercepts? So what I want to realize is the thing that's going to display the x-intercepts is when it's in intercept form, or we might think of it as factored form. So I am going to automatically just get rid of B and C because B is in just some in-between form and C is in vertex form. So they're out right away. Then I think I'm going to just use Desmos. So I'm going to jump over the Desmos, and what I'm going to do is just find the x-intercepts. So I hop in the Desmos, and I go 6x squared minus 45x plus 75. And I look at the x-intercepts. They are 5 and 2.5. Now I just look at the answers. They both are probably factored correctly, so that's why I don't want to factor this. What I want to do is I want to look for 5. Well, I see a 5 here, and I see a 5 here, but I don't see a 2.5 in this problem, and 5 over 2 is 2.5. So I need to see both x-intercepts as either constants or coefficients, so the answer is D. I'm sure this A is how you would factor this. And it's going to give us the x-intercepts, but the x-intercepts aren't displayed as constants. So again, 2.5 is not a constant or coefficient in this form, so that's wrong. All right, now on to number 15. So we look for value of n for which the system has one real solution. All right, so this is one where if it were multiple choice, I would definitely use Desmos. But I'm not going to, because I don't want to take the chance that I'd have to use a slider, and the answer could be bigger than 10, or it could be a decimal, and I don't want to have to go through that. So then my backup option is I know that I can just use the discriminant. So I'm going to plug in 4 here. So I get 4 equals x squared plus 12x plus n. So I'm just doing like substitution. Then I have a quadratic that I want to equal 0. And then I'm going to use the concept that when I want to know the number of solutions to a quadratic, then I look at the discriminant. And b squared minus 4ac has to equal 0 if we want there to be one solution. That's because that's what's under the radical, and if you were doing the square root of radical in the quadratic formula, you'd be doing the square root of 0, and square root of 0 is 0, and plus or minus 0 doesn't change anything, so you get one answer. So my b squared is 12 squared, so I get 144, minus 4, a is 1, c is n minus 4. This is the entire constant. And then I'm just solving this. You could hop over to Desmos now if you felt like it to just solve this. I am going to do it this way. I'm going to bring the 4 times n minus 4 over, divide by 4, and get 36 equals n minus 4. So add 4, so the answer is going to have to be 40. So again, if I had used Desmos, I mean, the odds that I'm going to just make it up to like 40, again, guessing and checking and see how things move, you might have a really good feel of that, and you can get 40. And if you could do that quicker than I can do this, then go for it. But I really don't love using Desmos on these types of problems with sliders where there's no multiple choice. I like to use the actual like kind of conceptual way or school way to do it. So again, both are important to know. All right, moving along here. If I want the minimum value of b is y. I want the smallest value of y for this systems of inequality. So I'm just going to hop over to Desmos on this one. I'm not even going to think about it. Systems of inequalities are just kind of a no-brainer. Use Desmos. So y is greater than or equal to 2 times x minus 3 squared plus 5. And then I'm looking at y is this time less than or equal to x plus 3. And I'll get this kind of in focus here. Now, this is super important. The question asked for the minimum value of b, but b was just y. So the answer, the solution set, or the solution region is this like double shaded, the black and purple. But if I want the smallest value that y can be, a lot of times we just look at the intersection points, but I want this point down here, right? This is the lowest y value that we could possibly have is 5. So the answer to the question is 5. All right, so anybody can use Desmos to graph that, but the concept here is understanding that you're looking for the lowest y value in the solution region. Number 17, biology students grew a culture. All right, I'm going to kind of skim through this and then, all right, which can be used to correctly calculate the number of spores in the bacteria culture at the end of 3 days. All right, so we obviously start with 200, but every answer has 200, so that's not really helpful. And it doubles every 12 hours. So basically what we have is 3 times 2 to some power. So now I can get rid of, I think, D and A. I hope I don't regret that because they could have, like, I don't know, messed with it a little bit, but let's see. And then, yeah, so we want to know how many, basically we want to know how many times it doubles. Well, if it doubles every 12 hours for 3 days, it's going to double twice a day, and twice a day for 3 days is it's going to double 6 times. So I'm going to take the initial amount and I'm going to double it 6 times. Oh, I don't know what I'm doing with this 3 there. I hope everybody was realizing that that just didn't make any sense. So that was obviously supposed to be 200. So yeah, the initial amount's 200. That gets multiplied by 2 6 times. So the answer is C. All right. We want to talk about the means and the standard deviations. So we want to be able to get them. The standard deviation is always going to be a conceptual question. The mean we could find, but we want to like stay away from actually calculating it if we can, because it could take a little bit of time, and any time that it could take would be wasted time, unless we had to. So this one we don't have to. They're both symmetrical and evenly spaced out. So the mean of both of them is just going to be 4. You can certainly check that, but it's not necessary. The mean and the median are going to be equal, and they're going to both be 4. So the mean of them is the same. So the means should be equal. All right, so now we're down to C and D. And then we want to see which one has a larger, which one has a greater standard deviation, or just, which is the smaller standard deviation, which one's the larger. So standard deviation is a measure of spread, or just how, the average distance that each data point is from the mean. Well, what's going to end up happening is they each have 3 points, really 6 points that are out here. But the thing is, this one has 2 extra points that are going to contribute 0 to the standard deviation because they are actually at the mean. So this one has a greater percentage of its points that are at the extremes. So that's going to lead to a higher standard deviation. So the standard deviation of J is actually going to be greater. So this is a pretty hard problem, because usually you just look at the extremes, and whichever one has more extremes is going to have a higher standard deviation. But then, since they're the same, you got to look. And the one that actually has more in the middle is going to then have a lower standard deviation. Because again, it has more, this one has a higher percentage of values that contribute to 0 in its standard deviation. So its overall standard deviation is going to be lower. All right, moving on to number 19. We're getting towards the end here. So this is one that some students really like to use Desmos. You can certainly plug it in. You got to be able to find, so obviously if we're looking for circumference is 2 pi r, or pi times diameter. So you just got to be able to graph it and then find the diameter, which you certainly can, but you do have to do a little bit of calculations. Not hard calculations, but you do have to find like the highest and lowest point, or the rightmost and leftmost point, and figure out, how far they are. It's not like Desmos just comes out and says like, hey, this is what the diameter is. So you do have to do a little bit of work, and you have to type it in. So the way that I like to do it is, and I'm going to illustrate more of this, but I would do it more quickly if I were just doing it. So what I'm going to do is just complete the square twice. So half of 6 is 3, 3 squared is 9, half of 4 is 2, 2 squared is 4, which means I'm adding 13 to this side. Well, if I'm doing this problem, I only care what's on this side, because this side is what represents r squared in the standard form of a circle formula, which means that r is 8, and then when I sub in 8 up here, I just get 16 pi. So I feel like I can get that really quickly just by adding 9 and 4 to this side, and pretty much doing it without much work at all. But if that's troublesome for you, then just use Desmos and make sure when you plot a circle how to which points to highlight, and how to find the diameter or the radius. And again, I'm ignoring this side, but just to go over the concept, this would be x plus 3 squared, and this would be y minus 2 squared, because the standard form of a circle is x minus h squared plus y minus k squared equals r squared. I would have focused on the left side if they asked for the center. The center would have been -3 and +2, but they didn't. So that's why I just ignored it and wanted to kind of show you the quickest way to go about getting that. But who knows? Some of you might be able to just type that in super fast, find the radius, and do it quicker than I did, but this would be the quickest way for me to figure out the radius. All right, number 20. So this one is hard and kind of not much to do at the same time. Typical SAT problem. So we want the value of sine of ABD minus the cosine of DBC. So first of all, this you can't do opposite over adjacent for the sine of this, because this is not even a right triangle. And then same thing with cosine here. The concept is, the point of them giving us this is to tell us that the two angles that we're trying to find the sine and cosine of, they add up to 90, which means they're complementary. And any time you have two angles that are complementary, the sine of one is always equal to the cosine of the other. So therefore, when you subtract them, you're just going to get 0. Now, to further explain why that is, just imagine we had an actual right triangle, all right? And I looked at this angle was my, one angle, and this was the other angle. If I wanted to do the sine of this angle, that would be the opposite, let's just call this A, over the hypotenuse, let's just call that C. And if I switched over and did the cosine of this, well, the adjacent would just be this same side, which was the opposite for the other angle over the hypotenuse. So you would always get the same answer because you're just flipping to the other angle. So in general, it just means any time two angles add up to 90, then the sine of one will equal the cosine of the other. Just try it in your calculator. Do like the sine of 70 and the cosine of 20. Or do the sine of 50 and the cosine of 40. They're always going to be equal to each other. So therefore, this problem really is just seeing that and realizing that, well, no matter what they are, when I subtract them, I'm going to get 0. Hard problem, though. Really hard problem, I think. Okay, now on to number 21. I'm going to take an odd approach to this, I think. We definitely could use Desmos. We definitely could use the discriminant. But if I notice that this is x squared minus 36, right, I'm going to just sketch this out. I'm not even going to jump over to Desmos because I know that x squared minus 36 is a parabola where this value is negative 36. And I know that y equals k is a horizontal line. So if I want there to be no solution, I just need that horizontal line to not intersect the parabola. And in order for it to be an integer and have no solution, to be the largest integer, I just need it to be 1 unit below this, which is negative 37. So honestly, I think that's the quickest way. But you certainly could use Desmos, and then you actually see that. Like if you didn't know that this was the graph and you wanted to just throw this in, you'll do the same logic with Desmos. Or if you decide to put the k here, bring it over, and do the discriminant, the answer is negative 37, but I just thought that was a super fast way to do that. The last problem. This is a pretty challenging one. So we have this g function that we're trying, exponential that we're trying to build. And let's remember, exponentials are a, b to the x. And the a value is the initial value, and the b is the base. So if it's telling us the base is k, and k is the y-coordinate of the y-intercept, which is the initial value. So they're telling us that this is k times k to the x. That is what all of this is saying. And then they want g of x minus 1. Which is k times k to the x minus 1. Right? I'm replacing x with x minus 1. And then I want to know which one of these answers is that. Well, I don't see that here, which means I need to do maybe a little bit of simplifying. So this is an exponent of 1. And when I multiply like bases, I add exponents. So x minus 1 plus 1 is x. So I just get k to the x, which is answer choice A. All right, that is the end. I hope you found that not only this video helpful, but all 3 videos that I made where I just solved every problem from the first module and then the easy and now the hard module. All right, see you later.